So parent functions, we have all these different shapes and they each have their own name. The shape and where each of these graphs are located that you see at the top of your paper, those are all the parent ones. They have not been translated anywhere, but that's what we're going to do for the rest of the lesson. So here's where they start. If you have a constant function, it means that the number your equation equals, f of x or y equals, it equals the number that your graph goes through on the y-axis. So this equation would be f of x equals 2, or 4, that's going through 4, and you'd have a straight line. You have a linear function, something that looks like a line, anything besides a horizontal line or a vertical line, and the equation is f of x equals x. I'm going to point out the exponent on the x. It's a 1. We normally don't write it, but it's there. It's a tiny little 1, and that means we have a linear function. So the shape is a perfectly straight line. The parent linear function goes right through the origin at 0, 0. The next parent function is absolute value. Absolute value looks like a V. The vertex right there is at the origin, 0, 0, and around the x are absolute value bars. That's why it's called absolute value. Moving on to quadratic. You'll notice we have f of x equals x to the second. That little tiny 2 right there means that it's quadratic, and we're always going to have this U-shaped parabola. Parabola is the fancy name for it. The parabola's vertex is at 0, 0. Next we have cubic. Its vertex, the middle, is at 0, 0. Cubic functions have a little tiny exponent of 3, x to the third. So you'll notice we had x to the first, x to the second, x to the third. Could we keep going and have a parent function x to the fourth, x to the fifth? Yes, we could, but we're going to stop with cubic. We'll get to those later in the year anyway. The last parent function is the square root one. There is a square root sign around the x. It starts at 0, 0, and it's kind of like a sideways parabola, but just on the positive side of the x-axis. So let's see if we can identify parent functions by looking at the equations, and then figure out if we add and subtract numbers to them, what happens to them on the graph. The first thing I would do when trying to decide on a parent function is look at the exponent on the x. See how there is no exponent on that x? It means that it's a 1. Which parent function has a 1 for an exponent on the x? The linear. So this parent function is linear. Let's try 1b. We have the exponent. It's way out here, but the parentheses mean that it goes with the x, and it will go with the 2, but not right now. But that little exponent of a 3, that means it's cubic. All right, the sign in this problem didn't show up, but this is a minus sign. Which parent function is this? There's a square root sign around the x, so it's going to be the square root function. And the last one, this is x minus 3. The exponent in this problem is a 2. Exponents of 2 are the quadratic family, so this is quadratic. All right, so what do you do to decide on which parent function it is? You look at the exponent. Now we're going to figure out how these are transformed. Instead of all of these black dots being in the middle at 0, 0, they're going to be moved somewhere else. If you were in class, you would grab your graphing calculator, type the equations into the y equals menu, and then either hit zoom 6 or zoom 5 so that it centered the screen on your graph. But I know most of you don't have those at your houses. So I'm going to sketch a graph for you. It's your lucky day. So you can copy this down. If you do have a graphing calculator, you can practice typing this in and verify. tomorrow when you get to class, you can type it in and verify. But the linear function that is x plus 5 is going to be 1, 2, 3, 4, 5 units up, and then you'll have the line, just like that. Now we have to describe in words what the transformation is, and I just said out loud what it is. It is translated up 5 units. So you can just write up 5. Now for the cubic. The graph of a cubic function normally would look like this, but this one, I'm telling you, is going to have that little dot 2 units to the left. So we're going to write left 2. Go ahead and verify it on a graphing calculator. Now the graph for the square root function. If you type in the square root and then you end the square root hat and type -1, the graph is going to start right there, down 1 on the y-axis, and then it'll look like the square root function. So the translation is down 1. And last, the quadratic graph is going to look like a parabola. It's going to be a U shape. This one is going to be 3 units to the right. So that's where the vertex will be. And then you'll draw the parabola. Just a quick sketch of what these shapes are. This one was moved right 3. So now it's our job to figure out if we can go from the equation to the transformation without having to watch me draw a picture of it or without typing it into a calculator. Just like I said up here, if you're trying to figure out what the parent function is, you look at the exponent. So right there, that little tiny exponent, the b, we're going to fill in that the exponent tells the parent function. It tells you which one it is. You'll know the shape. Then you'll just have to figure out where it is. Well, if you look at this number right here, this plus k, that's going to tell you if you have a vertical shift. If you see a plus sign, it will be shifted up. If you have a minus sign, it will be shifted down, just like what we talked about yesterday. Notice how this is on the outside of any parentheses that may exist. Now we'll look inside the parentheses right next to the x. That sign on your sheet is x minus h. Since this is next to the x variable, the h tells you that you're going to have a horizontal shift. If you see a minus sign, that will be how far you move to the right. If you see a plus sign here, that will be how far you move to the left. If you think I'm going crazy and I put a minus sign with the right and a plus sign to the left and you know it's the opposite, it's because that's true. When you're inside parentheses, it's the opposite of what you normally would think. All right, I just say those are kind of in their own world. It's backwards inside the parentheses. When you're outside the parentheses, everything is like you normally would think it is. So just pay attention to the sign and do the opposite. The last thing that you'll see in an equation, we don't really have any of these today, but in the future, sometimes we have a number out in front. If you have a positive number, it means your parent function will open up. If you have a negative out in front, it means your parent function will open down. So for example, positive x squared for a parabola would look like that. Negative x squared for a parabola would look like that. So let's put all that information together and graph these on our own. The first thing we're going to decide is the parent function. So we look at the exponent. That's a 2. That means this is going to be quadratic. What do the quadratic parent functions look like? They are the parabolas. So we know we're going to draw a parabola, but where? Well, the number outside the parentheses tells us if we have a vertical shift, and it's going to be either up or down. This is going to be down 1 unit because it's negative. Down 1. Inside the parentheses, it tells us if we're going to move left or right, and it's the opposite of that sign. So normally we would think that a +2 means right 2, but it's the opposite. So we're going to say left 2. So instead of drawing a parabola at 0, 0, we're going to move to the left 2, down 1, put a dot, and draw that U shape. Let's see if you can try 2B. Hopefully you noticed this was to the second power, so it's also going to be quadratic. And that's what your final answer should look like. Hopefully that's where you drew it. For these last problems, you might want to flip your paper back over in case you forget what they look like. This parent function looks like the square root one. Where did it move instead of being right here at the origin? It looks like it moved 1, 2, 3 spaces backwards. So we'll say left 3. 3B is the U shape. It's the quadratic. And instead of starting right here at 0, 0, it looks like it's 1, 2, 3, 4, 5 units up. If you want to be really cool, you could write these equations out. It'd be y equals, it's quadratic, so it's x squared, and it's up 5, so plus 5. For the square root equation, if we go back and look at that, it's to the left 3, so that means that the opposite of left would be right, so we need a plus sign. And it would be inside the parentheses, or in this case, underneath the square root hat. See if you can try 3C and 3D. I'm not going to give the answers away. We can check tomorrow in class, and just make sure to jot down a question you have about this lesson at the very end.